Alright, so now we're going to be talking about functions. Yay! And the most important thing about a function is that it's a special type of relation where it pairs a domain with exactly one range. If you notice, I wrote that in caps, so imagine me yelling that at you. Exactly one range, okay? So let's talk about whether some things are functions or not. Okay, so I want to talk, we need to give the domain and range of the relation and tell whether the relation is a function or not. So the first thing I want to do is write down my domain and range. Alright, so my domain, you can do this, you can put a D with a semicolon, set 3, 5, and 4. And now we do not need to write 3 twice. Even though there's 2 3's, we only need to write it once, okay? And my range is -2, -1, 0, and 1. Okay, so is this a function or not? So back to the definition of a function. We have that each domain has exactly one range value. So for every input, because these are our inputs, there can only be one output. For every x, there can only be one y. Okay? But, so we have two 3's, or we have the number 3, and that has 2 different outputs. So that makes this not a function. Why? Because each domain value does not have exactly one range value. The domain of 3 is paired with the range values of -2 and of 1. So that is not a function. Next one. The next one looks like this. We have a mapping diagram. So the first thing we need to do is determine what our domain and range are. Our domain is -4, -8, 4, and 5. And our range is 2 and 1. So now we need to determine whether or not this is a function. So we talk about the definition of a function again. It is that each domain has exactly one range value. Well, if you look at this, -4 has one range value. -8 also has one range value. They might be the same range, but that's okay. We cannot have 2 of the same domain having the same range, or have different ranges, I mean. But we can have 2 of the same domain having the same range. Does that make sense? So this is a function. Okay, we have this graph here, and I want to know whether or not this is a function. So let's determine our domain and range first. And as you notice, like here, either this line or this line. So from here to here, because our x values are our domain, it includes all these values that belong here. So we're not just going to have points. So it's going to be like that first one where we had an inequality. And what is the farthest left that it goes? It's right here, and this is -5, 1. I should have wrote these, or -5, -2. And this point up here is 3, 1. This is -3, 1. And this is 1, -2. Okay, so the farthest left that it's going to go is -5. And that's going to be less than x. But x is going to be less than, what's the farthest right that it goes? 3. So this is our domain. And our range, what is the lowest point on this graph? -2. And that is less than our y, which is less than, what is the highest point on this graph? 1. Okay, now is this a function? Well, let's think about it. For almost every single domain value that we have, for almost every single x value, there is multiple y values. Or it has at least another y value. So this is not a function. And I'm going to give you a very easy way to understand why it's not a function, and a very easy way to determine whether the graph or graphs are functions or not. So, it's called the vertical line test. A vertical line test allows us to visually see whether or not a graph is a function or not. And how does that work? Well, when you think about it, a vertical line on a graph has the same x value for every y value. And I'm going to make a graph. And let's just do a vertical line right here. And let's start listing out some of our points. Well, we're going to have 0. So we're going to have 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. And what does that say about this? Is it a function? No, it's not. Because for every domain, we need one range value. If you notice, these are all the same domains, but they all have different range values, meaning it's not a function. What does that mean about a vertical line test? Well, it means that we can determine if a graph is a function or not, depending on where it hits vertically. If there is only one spot that it hits vertically, then it's a function. So if I am given this graph, we need to talk about whether or not it's a function. Well, if we take a ruler and go along here, and if it only crosses this line one time, then it's a function. However, so this is a function. However, if it crosses the ruler more than once, so right here, you see that we have two lines passing through the line of the ruler, then this is not a function. So that's a very easy way to tell if it is a function or not.